Tiga. Okay, good morning. My name is ATHACHAI SAIPRAWAT anak laki KIANG, and here is my group mini project, which is a 7-function LED lighting for Christmas with variety of brightness. We are from group lab session 1 and we are group E. This is a project by ATHACHAI SAIPRAWAT anak laki KIANG, Muhammad ISY HAFIY bin AFANDI, and Muhammad FAIZUDDIN bin ISMAIL. And the lecturers are Mr. Sofi Yahya and Miss Nodiana binti Sharifuddin.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FAIZUDDIN. I will present about introduction. First is background of this project. 7-function LED lighting with adjustable brightness and pattern to use in festive season. So we use a variation brightness for this circuit. We can see for reason of selection, improve the variation of LED's pattern. Second, LED variations means user does not have to buy a new product for every season. So we can see from the reason of selection, we can cut our cost because we just use a same product. We just not we can buy more product because can just use one product to variation for the objective. First, to construct program using assembly language that change output according to input. Second, to construct an LED Christmas circuit using a microcontroller, LEDs, and switch capable of displaying different pattern based on switch output input. To produce a Christmas LED lighting decoration with a variety of function using the same amount of cost as normal LED decoration. From this objective, we can see we use a variation function of LED patterns. For methodology, procedure, software, use, MPIDE, and produce professional. So we make a coding or program in MPL IDE and the circuit design in Produce Professional. We put the coding into the Produce to run the program. The procedure for operating circuit is as follows. First, turn on the simulation. Press any of the push buttons of the circuit in port C to pick up an LED pattern. Choose brightness from the DPDT switch at the dim or bright to stop the circuit and pick another pattern. Press the result button at port E. Then press any of the buttons to switch button again. For understanding, we can see in another page for and design schematic. Component 18F for 8 methodology. Second LED. Third push buttons. For double throw DPDT switch. Resistor, escalator and capacitor.
Assalamualaikum and very good morning. First, I'm here is want to talk about the flow chart. First, we go to start and we press the start and the process or the standby mode is ready. And after that, we choose the decision of to choose the pattern. For example, we choose a pattern 1. Pattern 1 make the LED is blink. So other than that, we go continue yes or no. If we go to yes, it's reset and go back to choose the pattern. This is called a recycle back to know the brighter the LED. For example, pattern 2 is brighter than pattern 1, so the LED is blink. And we continue to know and end. That's all from me. Thank you.
For the coding part, we have divided the program into three main parts, which is the main function, the pattern loops function, and the delay function. First is the main function, which is the include P184580 microcontroller library and the configuration of the program. Okay, and then we set the origin to hexa 0. After that, we proceed to the main function, which is setting port C as input and then clearing all ports of port D to set all of port D as output. The second part of the program is the pattern loops. So here is an example of the pattern loop 1. All other patterns are the same. Okay, first is testing if RC1, which is port C1, is clear. Then executes pattern if clear, which is uh, directing to the send function. If not, then the branch to pattern loop 2 will execute if bit test file port C1 is set. The second part is inside the send function, which we use the move literal W with binary value and then placing the binary value inside port D file. After that, we add a delay to produce a blinking pattern. And the final part, which is the branch back to send, which we use to repeat pattern continuously unless we press the reset button in the circuit. The branch P1 means that the program will loop back to the first pattern, which is P1, regardless of any other pattern number. And here is the third part of the program, which is the delay function. Here we use three variables, R1, R2, R3, and the origin starts at 300 hexa. We we use the value 8 in R3, 207 in R2, and 250 in R1, which is all a decimal value. And then we use a no operation, add in with decrement F, and then the branch no zero function. So, but at the calculation below, here you can see that the total delay for one delay function is 500 millisecond or 0.5 second, which is not considered overheat. Here are the results. When looking at table 3.1, here we use port A5 and port A7 with component crystal and capacitor of 22 picofarad, which is used for the PIC configuration. The second table, table 3.2, at port C, here, all of port C are input types with a 4.7 key resistor and a push button for each port. And table 3.3, which is at port D, all of port D are outputs with components 4.7 k resistor and LED red. And finally, at table 3.4, port E input output, we use port RE3 add in with 4.7 k resistor and a push button to act as a reset button. At port E, the input it is considered an input. Here are the simulation results. When pressing switch RC1, there is a normal blinking pattern with 0.5 second delay, and you can choose a brightness between normal and dim. All other LED are the same. At RC2, we have LED 14567 with 0.5 second delay, and the same type of pattern, only with different LED, starting from RC2 until RC6 with a variation of random LED blinking patterns. And at RC7, we produce a unique pattern which is blink all LED one by one in a sequential manner and reverse the sequence and loop again with 0.5 second delay for every blinking. Here are the discussion with the full description. Here, as you can see, we produce a we produce a small switch using the double pole double throw switch here, which allows us to control the 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 brightness of the LED. Here, as you can see at switch 1, if the switch is connected with resistor A and B, then LED red and LED aqua will blink at a dim brightness. This is because the current flow from resistor 2 and 1 to resistor A and B, which will produce a total resistance of 500 ohm. So the LED will blink in a dim pattern. Here at the second circuit here, you can see that switch 2 R3 and R4 are not connected to resistor RC and RD, so the total resistor for every wire is only 220 ohm. So both LED will shine at full brightness. For the configuration of the LEDs in Proteus, we switch the configuration from digital LED to analog LED so that the LED will simulate the real brightness of the LED when encountering different type of resistance in wires. And for
For
commercialization, we
commercialization,
move on to Faiz.
okay, for commercialization, is cost of project management. For cost of project management, the cost of project during the construction of this project is zero as there is no hardware required. The project runs solely using MPLAB IDE and Proteus software. So we use a software to make simulation for this project because we just use software and not use hardware. So the cost is zero. We can see to the circuit design. So that's all from us. Thank you.
So here for conclusion and recommendation. For the conclusion, our team have achieved all objectives mentioned in chapter 1 earlier, which is in the introduction. The first objective, which is to detect changes in input and produce different outputs. The second objective, also achieved, which is to construct a microcontroller circuit consisting of PIC 18F4580, push buttons and LEDs. The second objective, which is to produce a LED Christmas lighting with variety of brightness. Here, as you can see of our presentation earlier, our project has achieved all three objectives. And the recommendation for future project of same title is to use an easier programming language such as C plus or Arduino, which are easier to use for beginner programmers and which also shorten the length of the program, but can also display the same function as our project. Another recommendation is to use more LEDs or create a series of LEDs or arrays of LEDs for a single output pin to increase the amount of LED use. That is all from us. Thank you. So here are our circuit in Proteus software. So if we start the simulation, and here is switch 1, which is at resistor 11. If we press switch 1, here, as you can see here, the resistor are connected from resistor 1 to resistor A, and the same for all resistors. If we switch to the second wire, which is not connected to a resistor, then the LEDs will shine brighter than earlier. So if we want to switch to another pattern, we have to press the reset button here to stop the operation, and then we press switch 2. Here, as you can see, the LED starts to blink in another pattern, and you can customize the brightness of the LEDs by switching on from connecting resistor to resistor or connecting resistor to a normal wire here. So if we are to test all the other switch here, press the reset button and we proceed to switch 3, and we can play around with the brightness switch, which is a double pole double throw switch or the PDT switch. reset button, pattern for reset button, pattern 5, reset button, pattern 6, reset button, switch 7. As you can see here, I'm using the double pole double throw switch to control the brightness. And the pattern will loop until you press the reset button. That is all from our group design simulation. Thank you.